Imagine asking a specific question about a chart on page 47 of your company's 200-page financial report and getting an answer within seconds without anyone having to read through the entire document. Today, I am going to show you how that's possible using Visual Retrieval-Augmented Generation, in short, Visual RAG. Welcome everyone. If you have been following my channel, you have already seen how RAG can be implemented. But they still come with significant challenges when it comes to working with complex layout, charts, tables, and multiple languages. That is where Visual RAG comes in. Instead of trying to extract and process text from documents, Visual RAG treats documents as images, preserving the full visual context while still enabling powerful semantic search capabilities. By the end of this video, you will understand how Visual RAG can be implemented using ColQwen 2.5 based on Qwen 2.5 VL-3B-Instruct with ColBERT strategy for indexing and retrieval. How Qwen 2.5 VL-3B-Instruct can be used for generating response and architecture overview, and you will see a live demonstration of these technologies working together to answer complex queries about documents. So let's deep dive into the Visual RAG architecture using ColQwen 2.5 using ColBERT strategy. So here you can see that there is an interaction between the query encoder here in the left hand side, the green one, and the document encoder in the right hand side. So you can see that query encoder takes query as an input and it generates the embedding here, and similarly the document encoder takes document as an input and it generates document encoder here. So I'll just explain from the right hand text, and then later on just go to the diagram and explain that. So let's say for a query we have Q1, Q2, Qm as tokens, and the model generates embeddings for each of the tokens like EQ1, EQ2 and EQM. Similarly, for a document D, we breaks that into D1, D2, DM, and that model generates the corresponding embeddings as a ED1, ED2 and EDM. For each query token QI, the model finds the most similar document token DJ by computing the cosine similarity between their embeddings, and that is given by max sim between QI and D. D means entire document and QI means individual token, and that is defined by maximum of cosine similarity between EQI and EDJ. EQI is our query embeddings and EDJ is our document embeddings. So it's a maximum similarity. How it is found out actually you have to, so here if let's say this is EQ1, and then EQ1 go through this formula max sim of QD, so it interacts with each individual document token and it's find out where actually which document is giving the maximum cosine similarity. It considers that it finds out that, and same thing happens for each individual query tokens. So you can see here each individual query token is going, and then they are interacting with all the document tokens and finding out the document which is providing the maximum similarity. And finally, all these max sim, the results of max sim score, that's getting added and providing the final score, which you can see here, like the overall relevant score between the query and the document is the sum of these maximum similarities across all the query tokens. This is the way actually where final score gets calculated, relevant score gets calculated, and that score is used to retrieve the most relevant documents. So this is the ColBERT strategy. Now let's go into the ColPali. So this is the first thing. The PaliGemma is the visual model from the Google, that is a PaliGemma. So that is when this particular context, this particular idea, this novel architecture first got implemented. So you can see here that this model is based on visual language models to efficiently index documents purely from their visual features. So this novel architecture was first implemented using PalyGemma. So PalyGemma visual language models with ColBERT strategy, that ColPaly got implemented for the first time, and that particular architecture have been used in ColQwen. So in my implementation, I will show you that implementation of ColQwen, uh, where this ColQwen is based on Qwen2.5 VL3B-Instruct. So this model is basically based on vision language models to efficiently index documents purely from their visual features, allowing for subsequent first query matching with late interaction mechanisms. So this is one of the important point why it is called so ColBERT strategy, which I explained earlier, that is particularly called late interaction mechanisms. So diagram, you can see that uh, this is the standard retrieval mechanism, which uses the text chunking, text extraction, specific layout extraction, etc., etc. This is the novel architecture which they have implemented. It's called ColPaly, and here it is called Qwen. Want to give an example, then it would be like, let's say there are 3 pages of documents or 100 pages of documents, or it will convert that particular PDF page into image and consider that as a single document. So like if there are 100 pages documents, so 100 images will be there, and it will try to extract the visual features, the context, and store that and index that for further retrieval. And when we uh, we provide any query to get the details, then each of the individual query tokens will be interacting with each individual document tokens, which are the visual features which they have stored, and then maxim will be calculated, and the final score will be the sum of all the maxim scores, and based on that, the most relevant documents will be extracted. And those particular documents, if let's say that I'm extracting top 3 documents, so in that case those 3 documents will finally go as an input to the visual language model, which is Qwen 2.5 VL3B-Instruct here, and that Qwen 2.5 VL3B-Instruct will generate the final response, and which will be the output of this implementation. Before I deep dive into the code implementation, I want to tell what I am going to show you here. So what I've done, I have downloaded a few life expectancy related pictures from our World in Data website, and I'll just go through them. So you can see the first picture is annual death rate from all causes in 2021. Then annual death rate by age group, United States 2021. Then annual death rates in people of different ages by sex, world 2021. Then annual death rates at different ages 1816 to 2021 for France and South Africa only. And then sex gap in life expectancy in 2021. Inequality in life expectancy versus health expenditure per capita 2021, life expectancy 2021 in a given year, then life expectancy for different continents like Africa, world, Asia, Americas, Europe, Oceania, then life expectancy by sex, male and female, then probability of dying that year among females, and in France. The last one is remaining life expectancy at different ages in 2021. So these are all pictures, and my question is that how the life expectancy changes over the time for France and South Africa. This is my question, and this visual RAG implementation will be able to find out the correct answer from these pictures. Install the proper torch version. So what I would suggest, you go to this pytorch.org site, and then from there you select the appropriate operating system like Linux, Mac, or Windows. I'm using Windows, so I have selected here. Then pip installation, then Python, then appropriate CUDA software, whether it is CUDA 12.4, 12.6, whatever you have, choose the appropriate software for that, and then copy this code and run in your virtual environment, or you're in I would suggest to install it in virtual environment, because maybe sometime you are using different CUDA software for different installation of different softwares. So I have installed that I have installed 12.4 to run this, and then I have installed the transformers, which is specific version 4.50.3. At this point when I'm speaking, the latest transformers version is 4.52. Avoid that because this requires 4.50.3. Then use the Qwen2.5 utils, and for this I would suggest that you go for this specific version, that Qwen2.5 utils tcod 0.0.8, and accelerate, numpy, pillow, matplotlib, and that's all. And apart from that, if you are using GPU, then you will be requiring around 24 GB GPU to run this. And here you can see that I'm importing from ColPali engine. So just one moment, one more thing I forgot to mention. So this is, I have just commented out here, but you have to install this ColPali engine from Illuintech. And once you install this, then you will be able to import ColQwen2.5, ColQwen2.5 processor. This is the model, this is the processor. To this model and processor is based on Qwen2.5 VL-Instruct model. So if you want to use this one, then you have to install ColPali engine, and then from there you have to import that. And for visual response, you have to install Qwen2.5 VL for conditional generation and auto processor. And finally, from Qwen2.5 utils, you have to import process vision info. So first I have implemented a simple RAG class, which is visual RAG, and you can see here that you have to initiate this with retriever model and retriever processor. Retriever model and retriever processor is our ColQwen2.5 and ColQwen2.5 processor. Then VL model and VL processor, this is the visual language model and visual language processor for our case. Here it is ColQwen2.5-VL-Instruct 3B, and for processor is the corresponding processor. So once you initiate this class with these informations, you can see that we are initiating here, and then finally you can, this has mainly three main functions here. Those are index documents, and then another is a retrieve, and third would be the answer query. So the first function, the def that index documents, it takes the path of the folder where images are kept, and then it creates a list of those images, and finally it indexes those images. It just store in this list those images, and that is the indexing. And finally here it is creating a all embeddings list, and in that list it is calling retriever processor to process those images and generate the embeddings. Here you can see that embeddings equal to self.retriever model. Retriever model means it is calling ColQwen2.5 model to process those images and generate the embeddings, and then it is getting stored here within the all embeddings. And finally it is just returning the length of the images, and this is for printout, like how many images have been indexed. And then the retrieve functions. Retrieve functions is used to actually retrieve the relevant images based on the score, which I explained, like it does a maxim score, and then it sums all the maximum score for a specific query for all the query tokens and generate the final score. So here it does that, like you can see that it is calling the process queries, then finally it is generating the query embeddings, and once that query embeddings is done, then it is calling score multivector. This is the important function. It is calling that maxim functions, which is actually interacting, means all the query tokens or every individual query tokens is interacting with all the document embeddings, and it is creating it is getting a maxim score, means which particular documents is giving the maxim score. It is keeping that information, and then finally it is repeating that process for all the individual query tokens, and then finally summing up that and getting the max score or final score. And then it is based on that particular score, it is retrieving the documents. You can see here that it is stored top k scores, top k indices, and finally based on that this is the number of results that need to be returned. So here I have kept 3. I'll show you, and then those results are getting returned here. And finally, this is the answer query function, which is actually calling the self.retrieve function. So which I explained just above it. It is calling the retrieve function to get the results, and as I mentioned that this is called with 3. So that means that it will retrieve top 3 images with the correct responses, and these are the messages which is required to create a chat template for Qwen2.5 VL-3B-Instruct. So you can see that here first in the text I have mentioned that I have a question about some documents, then I'm appending the query here, then finally I'm providing that image that all the 3. So if I'm retrieving 3 results, so for it will rotate around 3 times for that particular image, and then finally I'll also appending that based on the document images provided, please answer my question in detail. And once this is done, then it is calling the VL processor, which I have initiated with Qwen2.5 VL-3B-Instruct. It is calling that, and it is calling apply chat template with all the messages which I have created at the top. And finally, this process vision info, if you remember, I'm using it from the VL utils, that Qwen VL utils. So this is finally being called here to get the inputs, and these inputs are then being used by the model to generate the IDs, and which is finally getting used in turn to generate the output text, and this is being returned. So this is our main expectation. So you can see that everything whatever I have defined, I have explained above, so that is being called here in the main function. You can see that this is the retriever model. So this is the means I'm just initiating the retriever model for ColQwen2.5, and you can see that attention implementation means it will check that if flash attention to available or not. If available, then it will assign flash attention to. This is for optimizing the transformer process, and if it is not available, then it will just simply assign that as a none. Then it is also initiating the retriever processor, which is called Qwen2.5 processor from pre-trained video called Qwen2.5 v0.2, and then this is the actual model which is responsible to generate the answer here. And this is the model which is being again from pre-trained, specifying the model name and all other uh, required parameters, then also initiating the VL processor, and finally you can see that I'm initiating the visual rag class with all those informations. And then this is document paths where actually I have kept those images, and these are just calling that visual rag.index documents. This is the first function which I explained. Then visual rag.answer query, this is the second function, third function which I explained, because answer query calls the retrieve function to get the results, and here I am providing 3, so I means that I want top 3 results. And this is the query I have mentioned earlier, like how does the life expectancy change over time in France and South Africa. So that's all. What my expectation is that I will get some answer for this query, some written answer. And also what I'm doing, I'm just saving these images here, so I'll show you the images once I run that. This now. Here it's already using 18.7 GB of the GPU. Yeah, so you can see that this has retrieved documents. So document 1 have the score of 19.3750, document 2 have score of 17.50, and document 3 has the score of 17.37. And let's find out the answer first. So this is a query: how does the life expectancy change over time in France and South Africa? Answer is certainly. Let's break down your question into 2 parts based on the information provided. So this answer is based on the 3 documents which have been retrieved by ColQwen 2.5 using ColBERT technology. So part 1, life expectancy over time in France and South Africa. France, period for life expectancy. The period life expectancy for France has shown a general trend of increasing over time. This is important, and this means that on average people in France can expect to live longer than those who lived earlier in history. And cohort of life expectancy, the cohort life expectancy also shows an upward trend, indicating that individuals born in recent decades can expect to live longer than those born in earlier periods. Then it is breaking down South Africa scenario. So for South Africa, it is telling that period of life expectancy. Similar to France, South Africa has seen an increase in period life expectancy over time. This suggests that the overall health and longevity of the population has improved. And cohort is that, like France, South Africa has also experienced an increase in cohort life expectancy, meaning that individuals born more recently can expect to live longer than those born earlier. Then the part 2 of the question, the part 2 of the answers, that life expectancy at birth by region. So it has done some more analysis, and birth by region, this is giving the answer. The document provides a map showing life expectancy at birth across different regions of the world. Here is a summary of the key points. So this is not specific to France and South Africa, but that model have found that this answer also may be interesting. Let's find out. So Oceania, generally high life expectancy with values ranging from around 80 years to slightly above 90 years. America's life expectancy is relatively high. Europe life expectancy is very high with values typically exceeding 80 years. And Asia life expectancy varies significantly across different countries, with some countries having life expectancies close to or exceeding 80 years, while others are lower. Then Africa life expectancy is generally lower compared to other regions, with values typically around 60 years to slightly above 70 years. So this is some kind of information. This is still related to France and Africa, because France is part of Europe and in general the life expectancy is very high. Then Africa also life expectancy is generally lower compared to other regions. Uh, so that's all, and let's see that uh, whether it has just saved those images or not. Yeah, so this is the first one, then second most important, and third most important. Let's see that what is the first most important here. That is great. You see that this is the only chart which has the information about France and South Africa, and you can see that this is the annual death rate, and it is gradually declining over the year. You can see for the France and South Africa both. It was somehow more. I think this is around the COVID time probably. The mortality rate was more for 25 years, 45 years old, and yeah, it was for 65 and 80 years or old also. The trend is same for both France and South Africa. Africa is little bit worst it seems, but anyway, the main thing is that that uh, life expectancy is increasing. And second one was that for all the regions, I think the part 2 of the answer has been taken from here. You can see that as it mentioned that Europe has a high expectancy, Americas have high expectancy, then Africa do not have uh, that much, which is around 60 years. And then for Asia also it is kind of varying between different parts. I think this area has kind of 80 years life expectancy, but here again it is around 60 70 years, like that, around 70 years. And then it is again more leisure. I think here I think it is around 60 to 65 years. So then result 3 is again uh, it is over the different regions. I think this is part 2 as well, because I think it has a clear information for Oceania, Europe, Americas, Asia, world life expectancy. So in short, what I would say that this has performed really nice, because uh, you can see that the first part of the answer, the life expectancy over time in France and South Africa. So only one chart which had this information, it has correctly picked up that chart, and it has mentioned that period of life expectancy for both France and South Africa separately. Then it has picked up result 2 and 3, these two charts, because these are also relevant from world perspective, which is also covering France and South Africa. I believe visual RAG is the way to go. What do you think? Have you thought about any application? If you thought about any application, then let me know in the comment section. And also uh, feel free to let me know if you have any questions about any of the implementation which I have shown here. Thank you.